All right, here we're going to be adding and subtracting rational expressions. Remember, rational expressions are things that can be written kind of as a fraction with a polynomial in the numerator and a different polynomial in the denominator. So our learning targets for this section is I can find the common denominator between two rational expressions, and then I can add and subtract the rational expressions even if they have unlike denominators. So the first thing we have to kind of go back and review is when I'm adding or subtracting fractions with unlike denominators, first I have to find the common denominator. So in this first example, 19 and 38 are not common, they're not the same thing, so I have to find my common denominator between the two of these. But I know that 19 times 2 will give me 38, so I'm going to use 38 as my denominator here. So then I have to fix my numerator based on that. Nothing happened to my denominator here for the second term, so I can leave the numerator alone. And I know that to get from 19 to 38, which is my new denominator, I multiplied by 2, so I have to do the same thing to the numerator of that fraction as well. So now that my denominators are the same, I can just add my numerators together, and my denominator stays the same. So I end up with 17 over 38. So the first step is I have to find those common denominators, and then I have to alter the numerator based on what I did to get to the denominator. So now we're going to do that using polynomials. So the first thing I have to do is find the least common multiple. So that is going to be what my common denominator becomes. So I want to find the least common multiple of 4x squared minus 36 and 6x squared plus 36x plus 54. So the first thing I want to do is I want to find the factors of each expression, right? So we're back to factoring our polynomials. Okay, so I know that I can pull a 4 out of both of these terms, so I do that here. And then I have x squared minus 9. But don't forget that here I see I have a subtraction, so this could be a difference of two squares. So now I ask myself, do I know the square root of this first term? Which I do. And do I know the square root of this second term? Which I also do, so then I can factor it out further. And I know that 4 is 2 times 2, that's the prime factorization of 4, and my x squared minus 9 becomes x minus 3 and x plus 3. That's our difference of two squares. That's how we get there. That's how we factor that. So then I factor the second polynomial, so I can pull a 6 out of every term, and then I'm left with a much simpler polynomial, trinomial, and I can factor this as well. So I know that the prime factors of 6 are 2 and 3, and then this x squared plus 6x plus 9, if I was to factor that out, becomes x plus 3 times x plus 3. So now that I've found this, I have to write the prime factor the greatest number of times it appears in either expression. So here I have 2 times 2 times 3, right? My 2 times 2 times 3, and I only use 2 2's instead of 3 because these are shared. So I've got 1, and then the circled ones count as 1, and then there's my 3. Okay, so then I've got an x minus 3 right there, and then I have an x plus 3 and an x plus 3. And again, these are the same between the two, so I only write it once. So that's what I've got here, and then my extra x plus 3. So then I can simplify and find the least common multiple. Okay, so now we're going to use some of that information to add my rational expressions. So the first thing I want to do is I look at my two expressions, and I'm going to simplify once I add them. So step 1 is I factor the denominators, right? Factor as far as I can get them to be. So then I figure out what I have to multiply each numerator by when I have my common denominators. Just like we did when we were just talking with fractions, I have to do the same thing here. So I see that I've got an x plus 1 that's common in both denominators, so I don't really have to do much with that. But this x plus 4 is different, and this 3 is different. So to get my total final denominator, it's going to be all of those combined. So I know that this 1 I have to multiply by the thing that I don't have here, which is that 3. So I multiply by 3. And this 5x I know I have to multiply by the thing that I don't have in its denominator, which is the x plus 4. So I multiply, I've got my 3 in this numerator now, and my 5x times x plus 4. And then I can combine those two numerators, right? Because now my denominators are the same, and I combine my numerators, and I end up with 3 plus my 5x times x plus 4. And I'll go ahead and I'll distribute that right? So my 5x squared plus 20x, and then plus 3. And I just rewrote this numerator in standard form with the highest exponent first. So here's another example. So the first step that I would do here is I would factor both of my denominators. So I know that x squared minus 4x becomes x, and then I think of all of my factor pairs of negative 12 and what will get me to add to negative 4. And I know that a negative 6 plus 2, when I multiply, 2, when I multiply 6 and 2, I get 12, and when I add negative 6 and 2, I get 4. So I've got my x minus 6 and my x plus 2 for that first denominator. And I see I can pull a 4 out from both of those terms. So I go ahead and I do that. So then I have my x plus 2. So the thing that I see is similar between them, I have an x plus 2 in both of my denominators. So now I have to multiply what I don't have. So the thing that I don't have in this denominator is my x plus 6. So I multiply my 3x times that. And the thing that I don't have in this is that 4. So I go ahead and multiply. So I end up with 4 in my numerator there. And I end up with 3x times x minus 6. And all of that is over my common denominator, which is all of the pieces. So I had a whole number, and then I have x minus 6. So I go ahead and write the things that are different first, and then the thing that they share is this x plus 2. So now I can go ahead and continue to simplify. I'm going to distribute here. So then I have 4 plus 3x times x is 3x squared minus, because there's a subtraction here, 18x over my denominator, which was 4 times x minus 6 times x plus 2. And I can go ahead and rewrite this in the most standard form, which is going to be my 3x squared, because it has the biggest exponent, minus 18x plus 4. And then my denominator just stays the same. So I can do the same thing when I'm subtracting. The biggest thing is when subtracting is don't lose the subtraction sign or where it goes or distributing it. Okay, so again, first thing I do is I factor my denominators and then I multiply out what I need. Then I can do the multiplication and simplification and make sure I distribute that negative side where it needs to be. So here's the homework. These are things, we're not going to do this, but these have already been given to you in Khan, so make sure that you look through those and find any more examples that you need. Please email me if you get stuck.